We want to graph the plane x plus 3y plus 2z equals 6 and clearly label the intercepts. Notice how the equation contains three variables, x, y, and z, which means to graph the plane we'll have to use a three-dimensional coordinate system, often referred to as R3, pictured here. Notice how we have three axes, the x-axis, the y-axis, and the z-axis. Let's begin by looking at the graph of the plane using software. So here's the graph of the given plane. Notice how the plane has an x, y, and z-intercept, which we'll use to graph the plane on our paper. Let's review how we'll find the coordinates of the three intercepts. So again, to graph a plane using the intercepts, we find the x, y, and z intercepts, and then we form a triangle, which we see here to represent the plane. Again, this shows where the plane intersects the x, y, and z axes. Notice any point on the x-axis would have a y-coordinate and a z-coordinate of 0, which means in order to find the x-intercept, we set y and z equal to 0 and solve for x. Notice any point on the y-axis has an x-coordinate and z-coordinate of 0, so to find the y-intercept, we set x and z equal to 0 and solve for y. And finally, any point on the z-axis would have an x and y coordinate of 0, so to find the z-intercept, we set x and y equal to 0 and solve for z. So going back to our example, let's begin by determining the x-intercept, which means we'll set both y and z equal to 0 and solve for x. And we'll go ahead and show the substitution in this first example. So if y is 0 and z is 0, we'd have the equation x plus 3 times 0 plus 2 times 0 equals 6. This simplifies nicely to just x equals 6, which is the x-intercept. The x-intercept is the point 6, 0, 0. And now to find the y-intercept, we will set x and z equal to 0 and solve for y. So we would have 0 plus 3y plus 2 times 0 equals 6. Simplifying, we have 3y equals 6. So dividing both sides by 3, we have y equals 2. Which means the y-intercept is the point 0, 2, 0. And now to find the z-intercept, we will set x and y equal to 0 and solve for z. So if both x and y are 0, we would have 0 plus 3 times 0 plus 2z equals 6. Simplifying, we have 2z equals 6. Dividing both sides by 2, we have z equals 3. Which means the z-intercept is the point 0, 0, 3. And now we'll plot these 3 points and sketch our plane. And since the x-intercept is the point 6, 0, 0, this is the positive x-axis, so we'll go out 6 units here, and the x-intercept would be this point here, which again has coordinates 6, 0, 0. The y-intercept is the point 0, 2, 0. Here's the positive y-axis, so we'll go out 2 units. The y-axis to here, this would be our y-intercept. 0, 2, 0. And finally, the z-intercept is the point 0, 0, 3. Here's the positive z-axis. So we'd go up 3 units. And this would be the z-intercept. And the coordinates would be 0, 0, 3. Now, if any of the intercepts were negative, we would have to extend the axes. The negative x-axis would be in this direction. The negative y-axis would be in this direction. And the negative z-axis would be in this direction. But now to sketch our plane, we'll form a triangle using the 3 intercepts, which would look like this. Now the way these 3 axes are set up, it's consistent with what's called isometric graphing paper, but sometimes you'll see the 3-dimensional coordinate system oriented in this way as well. So let's take a look at a second example and graph the plane, again using the intercepts, using this three-dimensional coordinate system. We'll use the same process to find the intercepts. So to find the x-intercept, we will set y and z equal to 0. This time we won't show the substitution. Notice if y and z are both equal to 0, it would just give us the equation 2x equals 8. So if 2x equals 8, and we divide both sides by 2, notice how we have x equals 4, which means the x-intercept is the point 4, 0, 0. And now to find the y-intercept, we'll set x and z equal to 0 and solve for y. So looking at the equation, if both x and z are equal to 0, we would just have the equation negative y equals 8. If it's helpful, we can think of this as negative 1y. So to solve for y, we would divide both sides by negative 1, and therefore we have y equals negative 8. So the y-intercept is the point 0, negative 8, 0. And finally, to find the z-intercept, once again we set both x and y equal to 0 and solve for z. So again, looking at the equation, if x is 0 and y is 0, we would just have the equation 4z equals 8. So 4z equals 8, we divide both sides by 4, we have z equals 2, which means the z-intercept is the point 0, 0, 2. So looking at the three axes, this is the positive x-axis, this is the negative x-axis, positive y-axis, negative y-axis, positive z-axis, and negative z-axis. So the x-intercept is the point 4, 0, 0. So we'll go out 4 units on the positive x-axis here. This should be the x-intercept. Now the y-intercept is 0, negative 8, 0. Here's the negative y-axis. So we'd go out 8 units to the left, which should be here. Again, this is the y-intercept of 0, negative 8, 0. And then finally, the z-intercept is the point 0, 0, 2, which should be up 2 units on the positive z-axis. So we have the point again 0, 0, 2. And now we'll form the triangle to represent our plane. This would be the graph of the given plane using the intercepts. Another way to graph this plane would be to find the xy, xz, and yz trace, which would give us these 3 lines where the plane cuts the xy, xz, and yz planes. I hope you found this helpful.